Welcome back. So we're going to continue our example here, and just a recap from the last example where we introduced logical variables and relational operators in the context of a water tank where we tested to see if the turbidity reading on a given day or given time was within the threshold of being less than 5 NTU. We're going to expand this example, and we're going to start by showing how MATLAB can determine if the water in the water tank is safe given a vector input of turbidity readings and not just one value. So let's say we have 5 days of data and we want to look back and check the readings to see if it was safe for those 5 days. And I'm showing here the 5 days of data. They are 5.6, 5.3, 4.9, 4.8, and 5.1. If we want the turbidity to be less than 5 NTU, then we hope that MATLAB will give us a vector of true, false logical variables that is true only on the 3rd and 4th days. So that would essentially give us a vector with 5 values. They're all logical. First one will be 0. The second one will be 0. The third will be 1. The fourth will be 1. And then the fifth will be 0. So I'm going to pop back into MATLAB and show you how that works. All right, here we are back in MATLAB. So I still have my turbidity program up and available, and I am going to show what happens down in the command window here when I put in a vector for turbidity. So the values again are 5.6, 5.3, 5.4. Oops, that one's going to be 4.9, 4.9, 4.8, and 5.1. I'll go ahead and put a semicolon there. And now I have my vector. And then I'm going to, again, have is safe equal to turbidity less than the turbidity threshold. And you'll see that we get what we expect. The it is safe is false on the first, second, and last entry for the last entry, and it is true on the third and the fourth entries. All right, so let's go back now and add in another condition that our tank must meet in order to be considered safe. Okay, so we've only so far considered one variable to determine if the water is safe, and that was turbidity. In reality, in order for water to be safe, many conditions need to be met. So I'm going to now introduce a second variable that we need to check, and that is water temperature. So the water will be safe to drink if the temperature is between 10 and 35 degrees. If it's below 10 or above 35, there could be microbes that are growing in the water that could be dangerous. So we're just going to concentrate on temperature here for a minute, and we'll come back and add turbidity after we talk about temperature. So for the temperature, when the temperature is between 10 and 35 degrees, we normally write this as this type of inequality where we say the temperature is greater than or equal to 10 and less than 35. It shows up all in one line. Unfortunately, MATLAB cannot use this type of expression. It can only have one relational operator in any given expression. So instead, we need to break it up and introduce logical operators. So we're going to have to test if the temperature is both greater than or equal to 10 and temperature less than or equal to 35. So this and is what we call a logical operator. And let's just remind ourselves about all of the logical operators. So logical operators are operators that compare two logical variables to reach a logical decision. And there's many logical operators. These are just the 4 most common that you'll probably use. So the first is not, and it can be represented in MATLAB either as a tilde or using the built-in function not. And not just takes the opposite of a logical variable. So if that variable is true, it becomes false when you use not, and vice versa. The next one is and you can use either the ampersand or use the built-in function and. And is going to have a true result if both expressions, A and B, or however many expressions there are true. So they have to both be true in order for the and to come out as true. On the other hand, or, which is represented in MATLAB either as this straight line symbol, or you can use the built-in function or. And this is true if either of the expressions A or B are true, and it's only false if they're both false. The last one is exclusive or, which is represented by the built-in function x or, and that is true if one of the conditions is true, but not both. So let's practice this first using just true and false statements. So I'll go to the next page and we have this table here where I've given you different combinations for two variables, A and B. These are logical variables, and they're either true or false. And I've showed you both the numeric value as MATLAB holds it, which is zeros and ones, and then if that means true or false. So what I'd like you to do is just take a minute with these two tables and try to fill in the table to see when the conditions C, D, and E are true and when they're false. So go ahead and pause the video and come back once you have completed this quick task. Okay, I hope that you took a moment here, paused the video, and were able to fill in this table. But let's go ahead and look at the results. So you can see here, we're starting at the top in that first row. When A and B are both false, all of the other conditions will be false, okay? So A and B, both false, that's false. A or B, they're both false, that leads to a false, and same with the exclusive or. The next two rows, rows 2 and 3, are going to yield the same results. In both of those conditions, one is true and the other is false. So if one is true and one is false, then your and will be false, your or will be true, and your exclusive or will also be true. And last, if they're both true, that's the only time that your and will be true. Your or is also true, but the exclusive or is false because that is only true if just one of them is true. Okay, so let's bring back in that temperature data information. All right, so we're going to create this table here now where we test 3 different temperatures to see if the water is safe. So this would be using an and statement. We want the temperature to be greater than or equal to 10 and the temperature to be less than or equal to 35 for that water to be safe. So if my temperature is 15, what's going to happen is that the temperature will be greater than 10, so that's true. The temperature will be less than 35, that is true. So that means the water is safe. If I move to a temperature of 4, in this case, the temperature is not greater than 10, so that is false. The temperature is greater than 35. Sorry, the temperature is less than 35, that is true. But the water is not safe because that first condition is not met. And last, if I have a temperature of 38, that is greater than 10, so that's true, but it is not less than 35, that becomes false, so the water is not safe. So again, let's take a look at what this looks like in MATLAB.